All right, for example 2, an architect is designing a community park between North 1st Street and South 1st Street. The pathways on either side of the pool will be equal in length and will provide effective access and circulation around the pool. To protect the landscape and to minimize erosion, the architect will place a triangular section of triangular cobblestones at the corners along Park Plaza. What angle measure should the architect specify with the corners in her design? So what she's considering doing here is putting in cobblestones here. So basically look like that. She might have smaller ones, I don't know. And each one of these cobblestones should be the same angle measures as the triangle that's sitting right here. You can see here that North 1st Street and South 1st Street are marked as congruent to one another based on what it says. The pathways on either side of the pool are equal in length. And what I'm considering is that she's going to be doing this whole thing around here. I don't know. I'm not the architect, but cobblestones all the way around this path here. So that's kind of what's happening on this park. All right. So what you need to envision here is that each of these cobblestones should be a shrunken down version of this big triangle here in the middle that has a 50-degree angle up at the top. All right. Now, just a moment ago, we looked at an isosceles triangle where the angles at the bottom, the base angles, were congruent to one another, which made the two sides opposite congruent, right? And what I've mentioned already, the theorem, is that if this is true, if these sides are equal, then these angles must be equal. If the angles are equal, the sides must be equal. So again, just get that in your brain. That's always true about isosceles triangle. If you have equal sides, the angles are equal. If you have equal angles, the sides are equal. You immediately have that anytime you need it. But again, there's a theorem that allows us to say that. And as you can see here, that we've got 50 degrees used for this angle. If this is x and this is x, the unknowns, then we can see that 50 degrees leaves 130 degrees for the other two angles, right? So I know that x plus x should equal 130. Because 50 plus 130 is 180, right? So if 2x equals 130, divide both sides by 2, we get x equals 65 degrees. Now, it says, what angle measure should the architect specify with the corners in her design? So if I'm drawing a picture of this cobblestone she's going to be purchasing, right? It's supposed to have the same angle measures as the park itself. It should have a 50-degree angle at the top. It should have two base angles of 65 and 65. All right. I would answer it that way. One of those pictures worth 1,000 words type things. You could say, make the cobblestone so the base angles are both 65 and the other angle is 50 degrees. Or if you just draw a picture of it, that sufficiently describes the cobblestone.